Imagine seeing a cosmic bullet train rocketing toward us at 60 kilometers per second, 600 times faster than the world's fastest race car. That's exactly what 3I Atlas did before it even crossed the boundary of our solar neighborhood. But here's where it gets controversial. Does its blistering speed mean it was born among the oldest stars in our galaxy? Or was it simply flung out that fast at the moment of its creation? This is the question that sets off a debate about where interstellar travelers really come from and what they can tell us about the Milky Way. Before diving in, let's unpack why 60 kilometers per second is so astonishing. The fastest Formula One car barely breaks 0.1 kilometers per second on a racetrack. In cosmic terms, the average star in our galactic thin disk, where most stars form, drifts along at roughly 20 kilometers per second relative to its surroundings. Yet 3I Atlas barreled in at 3 times that value, the kind of speed one would normally only associate with high-energy gravitational slingshots around massive objects. Naturally, astronomers asked, does this speed imply 3I Atlas came from the ancient thick disk of the Milky Way, a stellar population that has been jostled for billions of years and now orbits the galactic plane at high inclinations and random speeds? Stars begin life in cold, dense molecular clouds embedded within the thin disk, a pancake of gas and dust that circles the galactic center. Over billions of years, these stars encounter spiral arms, satellite galaxies, and clusters that gravitationally nudge them, adding random motions. As a result, older stars drift farther above and below the thin disk, forming a puffier, thick disk. Since 3I Atlas arrived at a speed consistent with the random motions of thick disk stars, the straightforward reading would make its parent star at least 10 billion years old. And yet, that tidy explanation may overlook a crucial possibility. 3I Atlas might have been launched at high velocity during the violent process that created it, instead of simply inheriting its parent star's motion. In that scenario, its interstellar speed has little to do with stellar age. It could have been born hurtling through space at 60 kilometers per second. In fact, a year ago, my former postdoc Morgan McLeod and I described exactly such a mechanism in a peer-reviewed paper. We showed that rocky bodies can be torn apart and ejected at tens of kilometers per second when they venture too close to a dwarf star. Those common stars a tenth as massive and a tenth as wide as our sun. Because dwarf stars pack the same mass into a much smaller volume, their density soars to about 100 times that of the sun, which itself is roughly as dense as a solid. Under Einstein's insight that gravity is spacetime curvature sourced by mass density, the tidal forces near a dense dwarf star become powerful enough to spaghettify an Earth-like planet, literally stretching it into a stream of debris. Half of that shredded material escapes into interstellar space at speeds close to 60 kilometers per second. When I first jotted down the numbers on paper, it felt like a eureka moment, a natural way to launch an interstellar rock without invoking exotic physics. But 3I Atlas throws more curveballs than just its speed. It arrived on a retrograde path that happens to lie almost exactly in the ecliptic plane of our solar system, the disk in which Earth and the other planets orbit. A random arrival direction like that has a mere 1 in 500 chance of occurring. And there are additional puzzles. In the highest resolution images from the Hubble Space Telescope, 3I Atlas glows toward the sun instead of trailing a dusty tail. That implies it doesn't shed much fine dust because grains comparable in size to sunlight's wavelength would be swept back into a comet-like tail by solar radiation pressure. Spectroscopy shows it is unusually depleted in carbon chain molecules, meaning the reddening of sunlight it reflects likely comes from a solid surface rather than a dusty coma. Based on its brightness at 1 micron, measured by the SPHEREx observatory, its diameter could be as large as 46 kilometers, about 1,000,000 times more massive than the 2 previous interstellar objects, 1I Oumuamua and 2I Borisov. No known reservoir of interstellar rocks could supply such a behemoth over the Atlas survey period. The James Webb Space Telescope detected a plume dominated by carbon dioxide, 95% by mass, not water vapor. The Very Large Telescope recorded a sudden surge in nickel loss without accompanying iron, exactly the signature of industrial nickel alloy production. Boldly put, these anomalies elevate 3I Atlas to rank 4 on the so-called Loeb Scale, where 10 flags a technological artifact posing an existential threat to Earth. Picture stepping off the curb and seeing a race car barrel toward you with a 40% chance of an apocalyptic outcome. Naturally, you'd never take your eyes off it. Now, consider this. Just yesterday, a professional NASCAR driver emailed me. He wants to wrap his car in my face and name it the AV Loeb Special, timed to the predicted perihelion of 3I Atlas on October 29, 2025. As he put it, you're definitely a hot commodity in the NASCAR world. So whether you see 3I Atlas as cosmic debris or a disguised cosmic craft, it's screaming past us like an interstellar NASCAR, and the pit crew can only hope it behaves itself as it flies by. And here's the part most people miss. If 3I Atlas truly carries a technological signature, what would that mean for our search for extraterrestrial intelligence? Could it be a scout craft depositing sensor buoys in our solar system? Or is it simply a weird chunk of rock that coincidentally mimics industrial chemistry? Those are questions we don't shy away from, precisely because science advances by entertaining the unlikely. What do you think? Is 3I Atlas the wreckage of a planet shredded by a dwarf star, a natural oddball from the thick disk, or something far more intriguing? Share your thoughts and let's ignite a conversation. This mystery won't solve itself. The author, Avi Loeb, heads the Galileo Project and founded Harvard's Black Hole Initiative. He directs the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics and chaired Harvard's Astronomy Department from 2011 to 2020. He served on the President's Council of Advisors on Science and Technology and led the National Academy's Board on Physics and Astronomy. He is the best-selling author of Extraterrestrial, the first sign of intelligent life beyond Earth, and co-author of the textbook Life in the Cosmos, both published in 2021. His latest paperback, Interstellar, was released in August 2024.